In this video we are going to find the solution for test series 5, that is EDC MOSFET. Before that, this is ECE Tutor, so please subscribe to my channel, then only I can upload more videos. So please support my channel, please subscribe to ECE Tutor. So first question, for the N channel 0 bias depletion MOSFET circuit for below figure, calculate VDS if IDS is equal to 10 milliamps and VGS off is equal to minus 6 volt. And this is a circuit, and here ID is equal to 10 milliamps and VGS off is equal to minus 6 volt. So we have to find VDS and consider this loop, and this voltage is known as VDS. So consider this loop, that is, to find VDS, that is equal to VDD and VDD minus RL ID. So this is the equation considering this loop, VDD minus RL, voltage drop across this resistor, that will give that. Otherwise this equation come from this, VDD is equal to VDS plus RL ID. So the voltage, that is equal to voltage drop across this RL and this VDS. So from that we can find VDS is equal to VDD minus RL ID. So we know all the values. VDD is 18 and RL is 800 and ID is 10 milliamps. So 10 into 10 to the power minus 3. So that become 18 minus 8. So that will give 10 volt. So VDS, that is equal to 10 volt. So here the answer is A, 10 volt. A is the answer. Second question, an N-channel enhancement MOSFET has the following parameter: ID on is equal to 4 milliamps, at VGS is equal to 10 volt and VGS threshold is equal to 5 volt. Calculate its drain current for VGS is equal to 8 volt. So first, the formula for finding this ID, that is equal to K into VGS minus VGS threshold voltage, the whole square, and this is the equation for finding the current. And this K value is common for all VGS value. So first our step here is we have to find this K value. So K, from this equation itself we can find K, that is equal to ID divided by VGS minus VGS threshold, the whole square. And here ID is equal to 4 milliamps and VGS is 10, threshold voltage is 5, the whole square. So solving this we will get 0.16 divided by V square, microamps divided by V square. So now we get this K value, and again using the same equation, when this VGS is equal to 8 volt, find the ID value. Now we know the K value. This K value is common for all VGS value. So just to put all the value, that is ID is equal to K is 1.6 milliamps, that is 10 to the power minus 3 into, that is 8. Now VGS is 8, threshold voltage is 5. So now this equation, the whole square. So solving this we will get 1.44 milliamps. So ID, when VGS is equal to 8 volt, the current is, ID current is 1.44 milliamps. So here the answer is B, 1.44 milliamps. Next question, depletion MOSFET differ from a JFET in the sense that it has no PN junction, because in JFET 3 terminals are there, source, drain and gate, and there is no separation between these 3 terminals. But in MOSFET, the gate is insulated from source and drain using SiO2 layer. So here there is no PN junction formation. So here the answer is C, PN junction. Next question, for the operation of enhancement only N channel MOSFET, value of gate voltage has to be. And here in enhancement MOSFET, there is no channel between source and drain. So we have to give high positive, more than the threshold voltage. We have to give high positive, then only the channel induced between source and drain. So here this is N channel MOSFET, mean high positive is given to the gate. So here the answer is high positive. A is the answer. And fifth question, the main factor which differentiates the depletion MOSFET from an enhancement only MOSFET is the absence of. And in depletion MOSFET, there is a channel exit between source and drain. And in enhancement only MOSFET, there is no channel between source and drain. So the difference between depletion MOSFET and enhancement MOSFET here is the absence of channel. So here the answer is C, channel. VGS, that is equal to 0 volt. Here there is no VGS value. VGS is equal to 0 volt. So we know the formula, that is ID is equal to K into VGS minus VTH, threshold voltage, the whole square. So here K is equal to 0.1 and VGS is equal to 0.1 milliamps. So 0.1 into 10 to the power minus 3, and VGS here is 0, and here threshold voltage is minus 2. So minus 2, the whole square. So this become 0.1 into 2 square, that is equal to 0.1 into 4, that will give 0.4 milliamps. So here this is milli, so 10 to the power minus 3. So this is given as 0.4 milliamps. So here the answer is C, 0.4 milliamps. And this is VDS. At VDS is constant. So this is VDS value. So now we have to find the change in current first. So it changed from 2.2 milliamps to 11.8. So the change in difference is 11.8 minus 2.2. That is given as 9.6 milliamps. Similarly, we can find the change in voltage, that is equal to 2 minus of minus 2. So this is plus 2 volt and this is minus 2 volt. So change here is 2 minus of minus 2, that will given us 4. So now GM, that is equal to 4 divided by 9.6 into 10 to the power minus 3. So solving this, we will get GM is current divided by voltage. So this is 9.6 into 10 to the power minus 3 divided by 4. So that will give 2.4 into 10 to the power minus 3 Siemens. Otherwise 2400 micro Siemens. So that will 2.4 into 10 to the power minus 3. So if you multiply this by 10 to the power 3 divided by 10 to the power 3. So multiplying this 10 to the power 3 with 2.4, that will give us 2400, and this plus 3 come upwards as minus 3. So minus 3 plus minus 3 become minus 6. So this is equal to 2400 micro Siemens. So the answer here is 2400. So here the answer is C, 2400 micro Siemens. And next question, in a MOSFET, the polarity of the inversion layer is same as that of, and in MOSFET, the source and drain has similar polarity. That is, this is negative, means N, the N means this also N. So how you make, and this is insulating layer and upper this is gate. So how you make a channel between the source and drain means, if you give positive here means you can induce negative here. So it will act as a channel between the source and drain. So this source is N means channel also having the same polarity N. This is positive means this is also positive. So it is similar to what is the majority carrier of source? So the channel that is known as inversion layer, this channel is known as inversion layer. So this inversion layer has the polarity that is same as the majority carriers in the source. So here the answer is D. And next question, let VGS is equal to 6.9 volt. Calculate ID with the MOSFET parameter. ID on is equal to 5 milliamps at VGS off is equal to 4 volt. And here ID is equal to, it is IDSS into 1 minus VGS divided by VTH the whole square. And using this formula we can find ID here. And here IDSS is equal to 5 into minus 3 milliamps and 1 minus VGS is 6.9 and Thevenin is equal to 4. So solving this we will get 2.63 milliamps. So ID current that is equal to 2.63 milliamps. So here the answer is B, 2.63 milliamps. Next question, for an enhancement mode N MOSFET the threshold voltage is. For N MOSFET the threshold voltage is positive. For P MOSFET the threshold voltage is negative. So here this is enhancement mode N MOSFET, so the threshold voltage is positive. A is the answer. And next question, determine the source to drain voltage required to bias P channel enhancement MOSFET in the saturation region. Consider Kp is equal to 0.2 milliamps divided by V square. Threshold voltage is minus 0.5 volt and ID is equal to 0.5 milliamps and VSG is equal to 2.08 volt. And here we can use this parameter alone, we can find this and this parameter alone, we can find the VDS value, the source to drain voltage, that is source to drain voltage here is greater than or equal to this VSG minus this, this is P channel means plus this VTP. So this is a condition for saturation region. So this source drain voltage is greater than or equal to this VSG plus VTP. So here VSG is 2.08 and VTP is 0.5 minus 0.5. So minus 0.5. So solving this we will get 1.58 volt. So the required source to drain voltage here is 1.58 volt. So using this two parameter we can find the source to drain voltage. So here the answer is B, 1.58. Next question, N MOSFET, the region of operation of transistor is. In N MOSFET, this is N MOSFET, the region of operation is, and here VT is equal to 1 volt. And finding the region, if that is VDS, that is greater than or equal to VGS minus threshold voltage here. This is N MOSFET, so this is minus symbol. This is P MOSFET means we have to put plus symbol here. So if you satisfy this condition, the transistor operated in saturation region. So this VDS here that is equal to VGS here is 2 volt and this threshold voltage is 1 volt. So this is 1 volt here, but actual VDS is 3 volt. So this VDS now greater than, so it satisfies this condition. So we can tell that the transistor operated in saturation region. So here the answer is D, saturation region. Next question, due to the body effect in MOSFET, the threshold voltage. So due to body effect, the threshold, so the substrate and source forms a PN junction. So it increase the reverse saturation current. So it increase the threshold voltage. So due to the body effect in MOSFET, the threshold voltage get increased. So here the answer is C, increases. Next question, for an N-channel type MOSFET, if the source is connected at the higher potential than of the bulk, the threshold voltage VT of the MOSFET will. So now this V, that is the source and this is drain. This is source and this is drain, and this is known as substrate. So this is the basic MOSFET, and now this, the voltage between this source and substrate, this is greater than 0 means the reverse current, this form the PN junction diode across this source and substrate. So this forms the PN junction here, so it will increase the threshold voltage. The similar answer of previous question, the body effect and the this is known as body effect. So the PN junction is formed between source and substrate. This will increase the threshold voltage in MOSFET. So when this source bulk voltage is greater than 0, the threshold voltage of the MOSFET will increase. So here the answer is D, increase. And final question, when the gate to source voltage of the MOSFET with VT of 400 millivolt working in saturation is 900 millivolt, ID is 1 milliamps. Find the drain current for the applied VGS of 1400 millivolt is. And here we know the formula for finding ID, that is equal to K into VGS minus threshold voltage the whole square, and this K value is same for all VGS value. So if you take this as ID1, so this ID1 means this is VGS1 value, and similarly ID2 is equal to K into, here VGS value alone we have to change, other all are same value. So now we have to find this ID2 now. So take this as a ratio, this ID2 divided by ID1, that will give VGS2 minus threshold voltage the whole square divided by VGS1 minus threshold voltage the whole square. So that is the second voltage here is 1400 and threshold voltage is 400 millivolt. 400 millivolt the whole square. This one is 900 minus 400. So that, and this is 1000 and this is 500. That is, this is equal to 1000 into milli the whole square divided by 500 into 10 to the power minus 3 the whole square. So that is given as, this is given as 1 and this is given as, and this is minus 3. So this is given as 0.5 the whole square, that is equal to 0.25. So this is equal to 4. So now this ID2 divided by ID1, that is equal to 4. And from that we can conclude that this ID2 is equal to 4 times of this ID1. So this ID2 is equal to 4 times of ID1. So here ID1 is 1 milliamps. So ID2 is equal to 4 milliamps. So ID2 here is 4 milliamps. So here the answer is D, 4 milliamps.